Welcome to Eureka Math. I'm Mr. Schenkel. I'm going to be helping you today with fraction division models, part 3. These are fraction divided by fraction problems. Let's get started. All right, so we're going to model 1/2 divided by 1/3. And I think the best way to think about this and be able to model it is to change it to a multiplication question. And we know that we're going to get an answer here, right? We're going to find out what 1/2 divided by 1/3 is. It's some number. I just don't know what it is yet. And I can rethink of this as being 1/3 of that number, whatever it is going to be my original fraction, which is 1/2 in this case. So 1/3 of some number is 1/2. So when I look at that, it makes a connection here. 1/3 is 1/2. 1/3 is 1/2. We just don't know what 1/3 of what is 1/2. So we're going to use this idea to help us make a model. And here's how it's going to work. I'm going to model my second fraction this time. So when it's fraction divided by fraction, I want you to model your second fraction, and it will look like this. We're just going to use the box again. And if, let's say, it's that big, okay? And I'm going to split this into thirds. So we've got a line there, and we've got a line here. That's thirds. And then, again, we're going to shade whatever the fraction is. So it's 1/3 this time, so I'm going to shade one box. Okay, so there's my my fraction 1/3 modeled. And then remember I said 1/3 is 1/2? Well, that means that this 1/3 is 1/2. So however big that space is, in this case it's just one box, that's worth 1/2. So I know that that box is worth 1/2, and so is this one, and so is that one. So what's my answer? Well, the whole thing is my answer, whatever my whole model is, and I've got 3/2 here. So that's my answer, 3/2, which is 1 and 1/2. Okay, if we use the algorithm, 1/2 times reciprocal, we get 3/2, which is, there it is, 1 and 1/2. So there's the model. Let's try another one. This time I want to think of it. Let's do this first so we can get used to it. I'm going to change this to multiplication, which is 2/3. That's a bad 2. There we go. 2/3 of what number is 3/4? 2/3 of some number is 3/4. So now I know that 2/3 and 3/4 are going to be the same thing. So when I make my model, again, I'm going to model my second fraction there. So when I make my model, it looks like this. I'm going to split it into thirds again. And so like that. This time I'm going to shade 2 of them. So there's my model. 2/3 of the whole thing is shaded. And then I remember that I said, hey, 2/3 is 3/4. So all of this is worth 3/4. Now, the issue that I have this time is my space that's equal to 3/4 has 2 boxes. So I need to know what each of those boxes is worth. Well, if I split them apart, then 3/4 divided by 2 is what's happening. So I need to somehow get 3/4 here. Well, wouldn't that be 6/8? Wouldn't 6/8 be the same thing? If I doubled it, wouldn't this be 6/8? So I need to say that that's 3/8 and that's 3/8 And so, something wrong with my pen here. Sorry, this is also 3/8. Okay, and if I add them together, I get 6/8, which is equal to 3/4. So I know that this space here is worth 3/4, which is what I wanted. And now I can say that this box is also worth 3/8. So when I add all these up, I get 3, 6, 9/8 as my answer. 9/8 is the answer, which is 1 1/8 if I change it back to a mixed number. So 1 1/8 is my answer according to my model. Let's see if the algorithm holds true. We will multiply by reciprocal, and we get 3 times 3 is 9, and 4 times 2 is 8. So it is 1 1/8 with the algorithm as well. So the model works again. Let's try another one. 1/5 divided by 3/4. I'm going to remember that that is going to be equal to something. And then I'm going to change this to a multiplication question. 3/4 of some number, don't know what it is yet, is, I used the equal this time, is that okay? Same thing, is 1/5. Okay, so now I know that 3/4 is 1/5. They're the same. So I'm going to model my second fraction, which is 3/4 this time. Make myself a box. And I'm going to split this into 4 equal pieces. Okay, there's 4 equal pieces. I'm going to shade 3. There's shaded 3, so that's 3/4. That's my fraction. And then I remember that whatever this shaded region is, 3/4, is equal to 1/5. So now I just need to take that 1/5 and divide it by 3. So I'm going to multiply by 3 to make this 3/15. So that means each one of these is going to be 1/15. That one's a 1/15. This one's a 1/15. And if I add them up, I get 3/15, which is the same as 1/5. So that means this last one's also a 1/15. And altogether, my answer would be 4/15. So 3/4 of 4/15 is 1/5, is what it looks like based on our model. So let's check the algorithm, which is multiplying by reciprocal, of course. And when we multiply by reciprocal, we get 1 times 4 is 4, and 5 times 3 is 15, so 4/15. Bingo. The model worked again. All right. Let's do one more, just to make sure we've got it. I know that that's going to be equal to something, and so I can rewrite this as 1/2 of something is equal to 2/5. Oops, come on, 2. There it is, 2/5. Okay, so now I know that 1/2 and 2/5 are the same thing. So I'm going to model my second fraction, remember? I'm going to model that second fraction. There we go. I'm going to split it into 2. I'm going to shade 1. So here is, I found out why my numbers aren't working. My stylus is falling apart. All right, so there's 1/2, and then I remember, hey, wait a minute. I remember that whatever this is equal to 2/5. So if that one box is worth 2/5, then I know that the other box is worth 2/5, and if you add them together, you get 4/5. Check the algorithm. 2/5 times 2/1 is 4/5. And it worked again. I hope that helped. I'll see you again next time.